Alright, take one. This prototype board, when I turn on the LCDs and a LED stripe, takes 430 milliamps. I stopped using a 7805 or the LM1084s and started using a TPS 56637. Look at that. You can touch the board and it's room temperature. The LM1084 was white hot at 123 degrees. So the blue trace is at the voltage regulator. The peach one is coming in after a row of input capacitors, and the green one at the top is all the way at the end after all this. It's on the very end. If I turn off the LED stripe, this is what I now get as a volt. And if I turn off the LCDs, that's it. So peach is what my main circuit gets, and green, peach is over here, and green is by the time it's gone through all these other capacitors, that's what it's getting as a signal. Now, I wanted to clean that up more, so I tried something. So I added this bank of capacitors. I think those are 1s, those are 0.1s, and those 4.7s, all ceramics. They're coming right out of the board, the power supply, and then they go into the main board and go on from there. So yellow is that line, and as I turn on the LCDs, look at the current, the line has a lot less noise, and if I turn on the LED stripe, it's not so bad. The orange line is what the prototype board gets. The green is what it gets by the time it gets to the end of it. But look at that. This is with just the LCDs on. I'm getting only this. If I turn off the LCDs, that's the signal I'm getting. So I don't know why they didn't recommend adding a lot more capacitors on the output here. They recommended something like a maximum of 100. I remember there was a range, and I tried to stay within it. But here I've added, I think it's 640, 480, something like that, then 100 tantalum, and then 10 tantalum, and then it's in ceramics I got 10, 1.1, 4.7, wait, 10, 4.7, 1.1, and 0.01. And at the LED stripe, I've got 2 1000, and I got, this is like a 640 or whatever it is, and that's the 400 one, and 100 tantalum, and a small row of ceramics that matches this guy. And at the transistor that pulses the backlight for the LCDs, all I have is 100 tantalum. And that is a lot better than what I initially started with. I was missing a lot of capacitors. I haven't done any other adjustment as someone had recommended under the LCD. I didn't touch anything under there yet. This was a preliminary test just to see how much I could clean up by adding capacitors. And with this, I'm happy. But I'm going to keep on improving because right now, power goes in one line and then it gets distributed by all these bridges. It goes across from rail to rail to rail. And there's too much possibility for ground loops. So when I made this, I added 12 individual power lines. So I'm going to centralize the power supply here and have individual positive, negative go to each rail. I know I could improve it even one more step because this rail is shared by these ICs under here, the inverters that are hidden under the rotary encoders. I've got 4 of them, and they share that rail with that PIC. That PIC shares that rail with that PIC. If I want to have it perfect, I would have 2 individual lines here, one feeding each side, but I would need more than 12 individual connectors to do that. So for now, I'm just going to redistribute this, split it up a bit on a larger cardboard, and put individual feed lines and see if that improves these signals a little bit, hopefully.